Hey guys, this is Mr. Riss here, and today what we're going to do is start P6, which is all about the unit circle. So this first section here, what I want you guys to do in day one is to complete this unit circle completely. You might want to go ahead and just Google an image to have it go through, but I'm going to explain kind of the basics of a unit circle, and it makes it easier to understand. One thing about a unit circle, it's called the unit circle because oh yeah, you can't use that. I have to annotate here. Whew, glad I didn't make that mistake. Just get my tools up here for you guys. It's taking a second. It's called a unit circle because the circle, perfect circle, has a radius of 1. So any direction we go is 1 length away. It's always 1 unit away. Now, how we can find those, or if we start with the unit circle, if we know that the center is at 0, 0, it's easy to find certain tick marks over here. If the center is 1 away, well, that'd be up 1, so this would be at 0, 1. This would down here be a negative, or 0, negative 1. This one over here would be at 1, 0, and this one over here would be at negative 1, 0. The question now is like, okay, what if we want to split those in half? Where are these marks located at? Well, we would know, okay, we know that's 90 degrees. This is like a 45-degree angle from here to here. So let me erase this work over here. Ooh, really delaying here. And let's think about some things we also know. If I were to take a triangle and make a right triangle here, that's what I'm doing here. I'm making a right triangle. Oh, that was terrible. Let's try that again, Riz. I'm taking and making a right triangle. Better. If I could find the length of these two legs, A and B here, I could figure out how far over our X value is and how far up our Y value is. Well, the one thing in a 45-degree triangle, that these two angles are the same, meaning that these two sides are the same, so we can both call them X. And since this is a unit circle, we know that the radius is 1. So I can do Pythagorean Theorem here and say x squared plus x squared equals 1 squared, or 2x squared equals 1. X squared would equal 1/2, and when I take the square root of 1/2, it simplifies down to radical 2 over 2. So I would have to go over radical 2 over 2 and then up radical 2 over 2. Now the same thing would work on the other sides here, except for I'd be going to the left then up. So this is negative radical 2 over 2, positive radical 2 over 2. And this one down here would be both negative. I'd be going left and down, negative radical 2 over 2, negative radical 2 over 2, and the same thing over here. Negative, or this one would actually be positive radical 2 over 2. We'd go to the right, but we'd be going down, so on and so forth. Okay, now the other points, how do we get those in there? Man, this eraser is a weird tool. Still at 0, 0 here. Well, 45, 45, 90s are not the only special triangle that we could have. Oh, this is probably not going to be good. Oh, no. I do want to erase. So 45, 45, 90s are not the only thing that we could have. We could have 30, 60, 90s. And let's talk about why those are special. I guess I'm going to just have these scratch marks that are still left up there. All right, so if I were going to take a 30-degree angle here, 30-degree angle, 90-degree angle, this would be 60. Now, what's technically happening here is I could reflect that. I have another 60-degree angle here. What ends up happening is this is an equilateral triangle. So if this side is 1, this side would be 1, this whole length would be 1, and this would be 1/2. So if I was going to make a 30-degree angle here, I know that my Y would be 1/2 tall. Making a 30-degree triangle like how we do with the 45-degree triangle. But now I got to find my x. And I can do Pythagorean theorem again here. I can say x squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 would equal 1. X squared would equal, subtracted, 3/4. And if I take the square root of that, I would get radical 3 over 2. So I'd go over radical 3 over 2 and up 1/2. Now the 60-degree triangle or 60-degree angle is the same thing, except for now this leg's up is radical 3 over 2, and this is 1/2. So we'd go over 1/2 and up radical 3 over 2. Okay, so I want you guys to go ahead, fill out the rest of the unit circle because you guys will be able to use this on a test. I'm going to try to do my best now to erase some of these drawings here. Oh, I erased too much. Okay. I'm going to go ahead and just Google unit circle that looks good. And this is typically what I always do. So let's look at Google here. Hopefully you guys can still see this. Google unit circle. And if you guys want to do the same thing to help you out, let's try to find a good one here. All right, this one isn't too bad. It's actually, this one's really good. So a couple of things that I probably add to this unit circle here is just some formulas to help us out. So one thing to know here is like, okay, which one's sine? Is that the x or y? I'm just going to make a triangle here to help us figure this out. We know that sine SOHCAHTOA is the opposite over the hypotenuse. Well, every single hypotenuse is going to be 1. So the opposite side is the height here. This is the opposite, and this is the adjacent. So if sine is the opposite over the hypotenuse, in a unit circle, the hypotenuse is always 1. The opposite is always how tall this is, which is the y. So this is why the sine is always, the sine of the angle is always, actually I shouldn't use x here, that's bad units here. The sine of the angle, theta, is always equal to y. The cosine is the adjacent over the hypotenuse, which is why it's always equal to x. Now tangent is opposite over adjacent, so it is y over x, which that might sound familiar because y over x is the slope. So what you might want to do here is to just add more code to it and figure out what the slope of all these lines are. So I know the slope here is 0. So this is 0. Straight 45 is a slope of 1, because if I divide those two numbers here, y divided by x, it's 1. This one is straight up and down, so that's undefined. This one's back at 0. This is -1. This is a +1. This is undefined. And this is -1 slope. Okay, what's going on with these ones here? So the slope of 30 degrees, it'd be y, which is 1/2, divided by radical 3 over 2. Well, dividing by a fraction is the same thing as multiplying by its reciprocal. So 2 over radical 3. And so the 2's cancel out and we get 1 over radical 3, which cancels out to be radical 3 over 3. So this one would be radical 3 over 3. The opposite on the other side here is also radical 3 over 3. These ones are going down, so they're negative radical 3 over 3. And this one is also opposite over here, negative radical 3 over 3. What's going on with this one at 60? Well, it's the same thing, but we're going to flip these around. So that means our fractions are going to be flipped. It's going to be radical 3 over 2 times 2 over 1. Cancel cancels. We're just left with radical 3, which is steeper. So that's radical 3. This is radical 3. This is negative radical 3. And that's positive radical 3. So now we can use this and we can answer a whole bunch of different questions. So if I just simply ask you, okay, what's the sine of 5 pi over 6? You should know sine is the y. I go to 5 pi over 6. What's the y? Is 1/2. All right, and I could say, what's the cosine of 3 pi over 2? And you'd go, okay, cosine is the x. 3 pi over 2 is here. Okay, that would be 0. And if I could ask you, okay, what's the tangent of 7 pi over 6? Tangent is the slope. Here's 7 pi over 6. What's the slope? Radical 3 over 2. Only time where it gets a little tricky here is if I throw out some negatives, like what's the sign of negative 5 pi over 3. So 5 pi over 3 is going clockwise all the way around this way. So if I go negative, I got to go that same distance but backwards, and so it's over here. So here's negative 5 pi over 3. What's the sign? Radical 3 over 2. Now we can also use this, clear all my drawings, to find inverses. So if I ask you to say, okay, find the sine inverse of 1/2. Remember, sine is the y. What we need to do is find out on our unit circle now, we're naming the angle with the inverse. Where is the sine, the y equal to 1/2? Well, that'd be at pi over 6, and it's also at 5 pi over 4. So we're going to name both of those. All right, when's the tangent inverse equal to 0? Where's our slope equal to 0? Up at 0 it is, and at pi it is. So we name those locations. So hopefully you guys have done this before. I am not making you guys memorize this, but use the unit circle as your tool. So complete that chart, add any other pieces of information that you want on it, and use it. So best of luck on tonight's CYU, but I think you guys will be fine since most of you guys did this and it's the one thing you remembered from last year. All right, good luck.